some of you may be familiar with the mobile phone charging technology, that you place a phone onto a charging pad and you then charge your mobile phone without having to plug it in. Other people may have an electric toothbrush that you place on a little support and it will charge. Both of those systems are indeed wireless power delivery systems, but they only work over a very, very small gap. And what we're trying to do here is work on broadly the same technology but make it much more capable. And so what we're essentially doing with our research is making inductive power transfer systems that can operate over much larger air gaps. And we think that once they can operate over large air gaps, they become much more useful for lots of different applications. And actually the drone technology that you can see here being wirelessly charged is one of those applications.
So there's two main challenges. The first one is how do you generate this magnetic field and all the electronics behind it, and then the second challenge is how can you put all the electronics on board the drone, make them very small, compact and very lightweight, because the drone can't lift too much weight, so you don't want to be adding a lot of weight on the drone. So this is what these two challenges we managed to solve them to a certain extent. So our transmitter here can work very, very efficiently at very high power levels, and also, as you see on the drone here, we're being clever here by using the guard around the drone as the receiving antenna, and all the electronics on board are very, very small, such that they don't add weight to the drone. So this is what we developed, and this is the challenges that we've overcome.
With drone charging, ideally you would like to have a much wider range where you could charge the drone over, and this will charge within about 1 coil diameter. So if you look at the size of this, you've got basically a distance between the transmit coil and the receive coil that is about 1 coil diameter, so up to about here. There is a kind of fundamental limit as to what you can achieve in terms of distance. We think we can probably push it to around 2 coil diameters with improvements to the technology. So that means if you want more range, you need a bigger coil. So a bigger drone will be able to go further away, or a bigger charging pad means you'll be able to go further away. But I think realistically what we're looking at here is a technology that is lightweight enough that the drone can carry the receiver equipment, it can land on a charging pad, it can charge, and it can fly away again. And that massively simplifies the charging mechanism for an autonomous drone system.